One project that I'm doing right now that I find very exciting is we're working on a glucose sensitive tattoo that can be placed within the human body and will fluoresce near infrared light in response to the amount of glucose that's in your blood. So this is a passive way for diabetic patients to monitor blood glucose over very long term. And not have to resort to finger prick test, and we're the essential element there is that it's a special kind of nanoparticle that we have designed and pioneered here at MIT. It fluoresces in the near infrared, and that fluorescence, that light that it gives off, is modulated in response to the amount of glucose. So we actually designed a unique glucose recognition site. And this is a project that's being developed in partnership with Sanofi Aventis, and it's been a very productive collaboration both on the academic side, and it's leading to very exciting technology. The project is advancing probably the most rapidly of any in my career. We're in the second year of a 2-year exploratory proposal. We're already putting devices into animals for testing. So we're applying these structures inside of mice, and we're determining their efficacy. There's a lot that has to be done before these can be tested in humans. We have to look at long-term responses and toxicity, inflammation, but the concept is there, and the concept is really enabled by the findings of my research lab. It has the potential to be part of the solution of completely mitigating the disease of diabetes. So what happens is the negative consequences of the disease occur over time as the body deals with very sharp spikes in glucose and insulin, normally that follow meals. A single finger prick test, or even many finger pricks throughout the day, can't identify those very brief periods where your blood glucose will skyrocket. Over time, those events accumulate, and then later in life, or sometimes sooner, you suffer all the negative side effects of this disease, from blindness to required amputation to heart disease. So if you had a real-time monitor, if you were able to monitor glucose in real time and respond to these excursions of high blood sugar right away, you would be able to you would be able to intervene fast enough and stop these negative consequences. The technology that we're working on at MIT may form the basis of what's called an artificial pancreas. So this is taking the sensor and hooking it up to an insulin pump, where you'd have a closed loop. You would monitor glucose, and then in response, you would trigger an insulin pump. We have all the technology available to complete that loop, except for a viable long-term sensor that works inside the body. So that's what we're working on. And we have there's a lot more that we do in the biomedical space. We have a collaboration with Novartis Pharmaceuticals, where we're working on technologies that can design new types of molecular recognition sites. The ability to recognize molecules, it's central to the kinds of drugs that we use, to sensors and to catalysis. At the heart of these technologies often is the ability for some structure to recognize molecule A over molecule B. In the Strano lab at MIT, we're pioneering fundamentally new ways in which we can recognize molecules, and so that's a project that's been ongoing for about 1.5 years, sponsored by Novartis.